Alright, today we are going to be using the graphing calculator a lot to find our solutions to equations, okay? You have a couple of ways to do this, okay? You can type the left side of the equation in for y1, type the right side in for y2, and hit graph, and you're going to calculate all intersection points. So what I'm saying is, if let's say they gave you a problem 3x to the fourth equals, I don't know, 2x squared. Okay, if you go to y1, you type in 3x to the fourth. y2, you type in 2x squared. And then when you hit graph, you're going to calculate the intersection points. These would both a fourth degree. This one ends up being a parabola. This one's a parabola, and then wherever they cross would be your intersection points. All right, so here we go. Here's my equation. So I'm going to go to my graphing calculator, and y1 I'm going to type 3x to the fourth, and y2 I'm going to type 27x squared. Okay, you're trying to figure out when these two functions are equivalent to each other. So if I hit graph, and there's my standard window, and remember how we've been talking about you've got to be really careful on what you expect to see on these graphing calculators. I'm expecting to see several intersection points, and what it looks like right now is one parabola inside another parabola, and it looks like the only point they cross is there. Again, I'm old, I'm not smarter than you, I'm just older than you, and I've been around long enough to know, this isn't interesting enough. They probably need to cross somewhere, which means they're probably crossing somewhere up here and I can't see it. So I adjust. Oh, actually, I can only see one intersection point. So if you want to get a clue to what to set your window at, you can go to the table, and what you're looking for when y coordinates are the same, because when y coordinates are the same, you have found intersection points. And if I look right here, here, and here, you see how y1 equals y2, y1 equals y2, y1 equals y2? That tells me that's where those two graphs are going to cross, which they're not crossing here until like 243. There's my 0, 0 that I could see. But I can see from the table now that they're going to cross at a y value of 243. That tells me I need to adjust my y window to at least 243. So go to window, and I set it. I kept my x's the same because I don't need to see any wider. Okay, but my y's I need to see farther up, so I kept my y min at -10, changed my max to 500, and counted by 50s. And the more you do this, the more comfortable you'll get at picking your window values. And now can you see, or now I can see, and we can see all three intersection points. There's my -3, 243. There's my +3, 243. And there's my 0, 0. Okay? But, interestingly enough, if you don't want to go to table, because sometimes, I don't know, people like tables, don't like tables. If you look, we can actually calculate, we can make the calculator calculate the exact intersection points. And what you do is you're going to go to second trace. So if you hit the second key and the window key, this will come up. Not the window key, the second key and the trace key. Sorry, which is right next to the graph key. This window comes up because we want to calculate. And we're trying to calculate intersection points, so we choose 5. It's going to ask you a series of questions. First curve, second curve, and then a guess. When you're doing intersection points, not zeros, intersection points, really, the calculator is pretty smart. It's asking you for first curve. I'm trying to get this intersection point, so you don't want to be over here, okay? You want to be over here, and it doesn't matter if it's on the blue or the red, and I know sometimes it's hard to tell. That's why I use my color one to illustrate. I just first curve, I hit enter on the blue, and then it's going to come up and it's going to say second curve. So I made sure I was on the red, and I hit enter. And then it's going to ask me to guess, which I just hit enter again. There'll be one more screen in between here. I didn't want to print it. And just hit enter when it says guess. And you can see there's my intersection point, -3, 243. Yes, we saw it on the table. We already had the answer. But again, I'm teaching you calculator tricks here. All right, so now we have to repeat this process for this one and this one. Okay, so again, I start all over. You actually have to hit second trace again. Go to 5 for intersection. All right, and then first curve. Make sure you're on the blue. Hold on just a second. Hit pause. Okay, we're back. All right, so what's going to happen now is, oh, sorry, I already did this. Okay, so you're going to go to calculate intersection point again, but now you're on this one. So again, you want to just get in the vicinity around here, and it's going to ask you for first curve, and who knows if it's on the blue or the red right there at that point. And the calculator knows. You just got to be close to it. And you basically hit enter, and then the cursor will jump to the other curve and say second curve, hit enter. It's going to say guess, hit enter again, and then it'll finally give you the intersection point. So there's my 0, 0. We've got one more to go over here. So we start repeating the process all over again. We go to calculate intersection point again. Get over here somewhere in the vicinity, and you basically hit enter, 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 and it will give you the third intersection point. So again, my solutions are, what was this one? This one was -3, 243. This one was 0, 0. And this one is 3, 243. Okay? All right, so we can also actually do this another way. If I get 0 on one side of the equal sign, okay, so I would subtract 27x squared minus 27x squared. That would give me 3x to the 4th minus 27x squared equals 0. If I go to y equals and type that one in, okay, 3x to the 4th minus 27x squared, and I hit graph, or I set my window. I hit standard window and I didn't like it, so it was too squishy. So you can see the window that I chose, that's because I wanted to see the tops and the bottoms and the intersection points clearly. But the window I used to get this picture was -4 to 4, counting by ones. On the y's, I went -70 to 10, and I counted by tens. Okay, and you can see that I have an intersection point here, here, and here. So I'm going to, this time, I'm not calculating intersection points because I don't have two separate functions. I made it into one function by putting everything on the same side. So now I'm not trying to calculate intersection points. Now I want to calculate zeros. And this is a bit different. All right, so what you're going to do is you go to, oh, I skipped that step. You got to go back to second trace, and you're going to select 0. And then when you hit enter, it's going to ask you for left bound. Somehow you've got to get your cursor. If you want to trace your function from the leftist point to the rightist point. So you're tracing it like this. Okay, did you see me draw that? You're coming down, up, down, up. I'm tracing it left to right. Here's what you do for left bound. Somehow you use your right and left arrow keys. You want to get your cursor somewhere over here, okay? Somewhere over here. And then you're just going to start moving it. You're going to use your right arrow key so it'll come down, and you're going to get close to the 0, but you're not going to touch it. So you're going to stop about right here and hit enter. Then once you hit enter, it's going to say right bound, okay? And oh, look at this one. The cursor's up here. It says, but how do you know it's on the left? I can't see the cursor. Well, look at the y value. -3, 10. That means I'm over here at -3 all the way up at 10. I can't see it because my window isn't going that high. But I know I'm on the left. I know that I'm above the x-axis at this point. So then it's going to ask you for right bound. Right bound, left bound is before you hit the x-axis. Right bound is after you pass it. So go move your cursor a little bit past, stop it and hit enter. And then it's going to ask you to guess. Just hit enter again, and it'll give you the 0. So this point is -3, 0. And then you got to repeat for this one and this one. So go back to second, calculate 0. But now we want to we're figuring out this one. So I'm going to approach it from the left, and I'm going to stop before I touch it and hit enter. Then I'm going to go past it for right bound, okay? And I have to see here, and I'm looking, I'm trying to get that y to be, I'm trying to get that y coordinate to be positive, because here it's negative. I got to get above it, which means I'm looking for a positive y. So I'm looking at this value right here, and there has to be a sign change to bound to 0, and I'm not seeing one. Okay, so if I just trace it, I can see that it's at 0, 0. And that's because of one of those even multiplicities. Remember when it'll just come up and touch it and turn? It doesn't actually pass through it. So you're not going to get a sign change. So you got to be careful on the what we call tangent ones, the touch and turn ones. But there's a 0 at 0, 0. And then I have to do it again. Yeah, see how I just traced it? Okay. Actually, I got to 0 and I hit my right bound, because 0 doesn't actually have a sign. It's not positive or negative, but it worked. All right, so then I have to start all over again and do it for my third one. So as I continue to get the left bound, I'm approaching from the left. I'm going to get close and stop and hit enter. Then I'm going to go past it to get the right bound. Again, I can't see the actual cursor because it's way up there at 10, but I know it's positive, so I know I'm on the other side. Enter, and enter again, and there's your other 0. So I have zeros at negative 3, 0, 0, 0, and 3, 0. Okay? Alright. Oh, and by the way, when they ask for answers, you can answer with ordered pairs. It's not wrong, but generally you just list the x-coordinates of the x-intercepts. Alright, so let's try another one, solving it graphically. We're going to do this one where we type this side into the left, this side into the right. Okay, so I typed in, this for y1, this for y2. So I typed that in, I hit graph, and this is a standard window. This is what I saw in a standard window, and I can see that intersection point, but I think I'm missing one up here. So I'm going to adjust my window. Or I can look at the table, and I'm looking for matching y coordinates, and I got negative 4, 0, 0, 12, 12, which means my answers are negative 2, negative 1, and 2. But let's calculate them. So I adjusted my window. I know I've got to go up to at least 12. So I adjusted my window, and I went from negative 10 all the way up to 20 instead of 10. Oops. And I got this picture. So now I can see all 3 of my intersection points. Okay? So now we're going to calculate intersections. So we go to second, trace, calculate, choose choice 5 for intersection. And again, I want to be close to over here, so first curve, as long as hit enter, then it'll jump to the red, hit enter, and then it'll hit enter through your guess. And there's the solution, negative 2, negative 4. But I got to do it 2 more times. So I've got negative 2, negative 4. Hit second trace again. Calculate intersection. Now get close to this 0. Enter on first curve. Enter on second curve. Enter on guess. And that's negative 2, negative 4. I already got that one. Oops. All right, let's try this next one then. Right back up. Oops, I calculated the same one twice. I meant to calculate this one. Oops, I guess I should pay attention. All right, let's find that third one. Intersection. First curve, enter. Second curve, enter. Enter through the guess, and 2, 12. So I apologize on that one. We need to go back and redo that one. So my 2 solutions, this one was negative 2, negative 4. I'm assuming that that's going to be at negative 1, 0. And then this one is at 2, 12. So my 3 solutions would be negative 2, negative 1, and 2. Okay? Alright, so explain how to find all the roots of a polynomial function. Well, with the graphing calculator, you type it in and you calculate all zeros. How do you find the real zeros of a polynomial function given a graph? You look for x-intercepts. X-intercepts are real solutions to polynomials. Alright, so I'm giving you a little homework help. Oh, this is homework. Alright, so we're at homework, which means we are done. So, happy homeworking, and I will see you next time.